Hi everyone, and welcome back to the Beginner's FreeCAD series for version 1. In this video, we're going to be looking at non-planar attachment and modeling this model of a light fitting. We'll be learning how to create a polar pattern across a non-planar face, attaching the original sketch, and creating threaded holes. Through this course, we have covered numerous tools in the part design. The ones shown in the toolbar in the red are the ones that we've covered. In this lesson, we're going to practice non-planar attachment. By creating a light fitting, we'll use the non-planar attachment methods to position the holes around the sides of a circular surface. These holes will also be threaded. Briefly introduce two operations that we haven't used before, and these are shown in green. These are the hole operation and the polar pattern. Don't worry, we'll explore these tools further and in more depth later in the course. Let's take a look at what we're aiming for. Let's open up FreeCAD and learn how to use the part design to create this object. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-Fi at ko-fi.com/MANG0 or via PayPal at paypal.com/PayPalMe/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. So I've opened up FreeCAD and I'm in the part design. Created a new document. I'm going to start with a new body and then a new sketch. We will create a quarter profile to rotate around the Z-axis. For that, we need to look on the XZ plane, this one here, to allow us to rotate along this axis. Click the plane, and then we can start sketching. I'm going to keep to the left of the vertical axis. Using a line, we'll place in our first piece of geometry, which is just a simple line, and we'll set that to 50 millimeters and hit enter. We can still move the line up and down because of the angle, but I'm going to connect it to the horizontal axis with point on line constraint. You can see it kicking in there. And we've got our first line. Note that I've got, as usual, the auto constraints checked and the auto remove redundants. Click on the panel to clear that. Now I've got my first dimension in, I can resize the screen to make best use of the space by zooming in. Let's use the polyline. I'm going to hover over this point, click once, and start sketching, clicking the left mouse button to add in the constraints. Don't worry if we go off something like this, we can add in the horizontal constraint later. And we'll just connect up this one and come down to the center point and finish our sketch. Right click to cancel the tool and right click to get the mouse pointer back. Let's clean up this line by using constrain horizontal and vertical and clicking on it. Any other lines that need that, we just come round and select those. We're all good. Right click to cancel the tool and we'll start using the dimension tool and adding in the dimensions. First one is the height here. Click once, bring this over, click again and type in 30 millimeters. Set the length here. Click once on the line, click again, and set this to 15. Going to come down and set this length. I've accidentally clicked on the vertex, so we'll right click to cancel and come back in, zoom in a bit and select that line. Bring this down. Set that to 2 mil. This height here going to be 15. The height between this point, selecting this point here, and coming down and selecting this point here. Notice we get the constraint that's coming in, and that is constraining to the center point. You notice it's going over constrained. So we need to come in and look at this point, hover over it, click once, and then move to the side and click again and set this one to 2 millimeters. We're starting to get the constraints restricting down the geometry, leading to being fully constrained. The next one I'm going to set is the angle between these two. Select one line, select the other, and now I can set the angle. So this is all done from one tool, the dimensioning. Let's come up this way. Click and set this to 120 degrees. We are now fully constrained. If we revolve this now, we will have all of this space in here solid. To save on the material, say if we 3D printed this, I'm going to add some more geometry using the polyline. I'm going to create a simple triangle within here, which is closed. Right click to cancel the tool, and we've got the mouse pointer back. We'll constrain these 2 points and place them horizontal, and these two, and place them vertical. Notice these can move now. I want to maintain a 2mm gap across here, and the same across here. We'll take these 2 points, place in a dimension of 2mm. Right click to cancel the tool, and to maintain the gapping, let's take this line and this line and make those parallel. We've now got the parallel constraint in here, and we're all constrained down. We'll still get the material in here when we rotate this. We're going to replace this with a threaded hole. Let's close our sketch. The sketch is already selected. If it's not, just click on the sketch in the tree view and use the revolution. It's revolved around the vertical sketch axis, which is in line with the Z axis. We can choose whatever axis we want from here. We could even go for the Z axis here. Let's hit OK. And now we've got the starts of our lamp fitting. Our next stage is to create holes around this edge. So we've got this non-planar face that goes around here. I can't select it and create a sketch because it's going to warn that you need a planar face. Hit OK. So we need to find something to attach it to. Now there is a seam that runs around the outside where the edges join. We use this seam to support our sketch. There is one thing that's missing from here, and that's a fillet that goes along this edge. Now we could select the edge and create a fillet, but I'm going to keep it all in the sketch. Let's come into the revolution and double click the sketch. Let's zoom in to the edge. I want to create a fillet across here. If we look to the toolbar, we can see the fillet tool. It's also available if we right click and create fillet. To add the fillet, select one edge, click once, select the other, and click again. We now have a fillet, and you notice this point here is still maintained for 2mm gapping. Right click to cancel the tool. Let's set the radius of this fillet by clicking on it using the dimensioning tool. Bring out the radius and set that to 2. We're fully constrained again. If I hit close, we now have our fillet. So back to attaching the sketch. We will attach the sketch to the base plane and then move it using the attachment modes that we've learned before to this edge here. Click once in some blank space so nothing's selected. That means when we create a sketch, it's not attached to anything except for the base plane. Look to the plane that most looks like the orientation of the sketch, which is going to be this one here on the reverse of the YZ plane. We click the YZ plane, we're actually sent round to the other side, the front of it, which is fine. Right click and use the view section, also the tool here. Look towards the origin point, and I'm going to create a circle that's connected to this point here. You can see that in there. Come out, say this far, right click to cancel, and then set some dimension. Now, because we're going to use the whole operation, it doesn't really matter what dimension this is. The whole operation will override that if we use an ISO standard. Let's add some dimensions anyway by selecting it, selecting the dimensioning tool, and set the radius to 6 millimeters. When we close the sketch, we'll see the sketch is still in the center. If I select the sketch and come down to the map mode, so we change the map mode, which is flat face, to the YZ plane by clicking on it and using the button on the end, we can see it's mapped to the YZ plane and it's mapped plane face. We can change the reference. Click on the plane, it's saying selecting, and we'll come in and select the top vertex. That's positioned normal to that edge now. Click on reference 2, and we look for this vertex here. This is now at inertia 2,3. All we need to do is make that flat to that face. And we use these align options here. The way these work is that the first one is the origin, which is aligned to the first reference. Let's just click selecting on here so we don't select anything, and it replaces this. So this is the origin. The next one, in this case, will be the normal, which will be vertex 7. The third one, it isn't referenced, so it doesn't take any reference to that. So if I pick the line ONX, the origin will be aligned to vertex 4. That's the origin of the sketch where those two axes meet. And the normal of the sketch will be aligned vertex 7. So we want to align the X of the sketch to our second vertex, our second reference, vertex 7. We can now use some offset, and this will be in the X direction because remember, the sketch is now pointing the X toward this vertex, this one here. We'll look down in the X direction, and we can change this and move this into position. This is going to be a hole, so we don't have to worry about the overhangs. If it was a pad, then I would set it into the object slightly. If we remember back when we created the sketch on the plane, we wanted it on the reverse. The sketch flipped round to the front of that plane. So we can use the flip side, because if we applied that hole, we would have to apply it in the reverse direction. I'm not going to use that yet. I'm just going to hit OK, and we'll show what happens. Now we're going to apply the hole. Click on the sketch and use the hole operation. Click that. You can see nothing happens. If I select reversed, then it goes through. Let's cancel that and click on the sketch and come down to map reverse and set this to true. You'll notice something. The offset is now in the reverse direction. So before we offset this way, it's now gone up. Easy to solve. Let's come into the sketch. The offset is the attachment offset. So let's come down to the attachment offset. Look at the position. It is 7. So we just change this to -7. Place it back into position. Once we're happy, we can click on the sketch and use the hole operation. You can see the hole has taken effect now. The hole has a dimension, the depth. We can go through all, if we want to go all the way through there. But we have to be wary of where the hole exits. So I'm just going to a dimension. Look at the profile and drop this down. We can pick an ISO standard or a UTS. I'm going to go for the ISO metric regular profile. Notice the hole has changed. Let's set the dimension. We know the width is about 2 millimeters. We know the width is 2 millimeters. We'll just set this to say 3. So it doesn't come out the other side. So we can see the sketch doesn't dictate the hole size if we're using a profile. Let's drop down the size. Let's set it to M5. At some point, we're going to make the hole threaded. But I'm going to leave that for now because it saves on CPU time. It's important to note that the depth is best kept consistent to the model. Because we could set this to say 10, 12 millimeters, so it comes out to about here. If we used the threaded, then it will calculate the whole of that depth. I've just set mine to 3 millimeters. And we could set this to 2 mil for the thickness of that edge. Let's hit OK. That's our whole operation done. Now to add another hole, we could create more sketches along here, but there's no need to. I'm going to use a pattern. So this is a polar pattern. To use that, we select our operation, and then we select the polar pattern tool. It's going to ask us what axis we want to rotate this around. At the moment, we can see nothing's happening. The hole is in the feature, and we've got the transform tool shapes, which is selected. The axis is normal sketch axis. Let's drop this down and pick the Z axis, the base Z axis. You'll notice that we get a hole on the other side. I want 3 holes, so I can set the occurrence of the holes by bringing this up to 3. We get those evenly placed around the circumference of that edge. Notice the angle is at 360. Let's hit OK, and let's make our final hole. We need a threaded hole through here. Now there's another way of using the threaded hole, and that's not to use a sketch, but to actually use a face. As this face is circular, the hole will be placed at the center. So select the face, notice it's highlighted in green. Only select once because the second select will select the whole operation. The third select will select the body. So select once on the face, click on the whole operation, see the hole is being placed there. Use a profile, regular profile. I'm going to go for a size around about M24. So the hole is in here. You notice how it tapers at the end. And this is to do with the drill point. We have it angled at the moment. So I can control the angle of that hole. The dimension controls the depth. So I want to take it all the way out the back, and I want this tapering in here. If I bring back the depth, you notice it affects the taper. We can also affect the angle as well. For this hole, I'm going to use the threaded. Note the hole is actually smaller now to take account of the thread. You can't see the thread, and that's because the model thread hasn't been checked. If I select that now, and let's select Update Thread View, you notice that it recomputes. And this is the reason why we don't select this first. We use this as the last operation. We now got a thread in here. Let's hit OK. And let's click on the hole that's been patterned. If we look in here, we see the sketch, and the pattern itself is actually within this hole here. That may be a bit confusing. This is the last operation, so this is the operation here. We applied this hole to the face of the polar pattern that's within. Let's click on the original hole and double click on that. The features disappear because we're editing that operation, that feature. Let's make it threaded. Model thread. We don't have to worry about updating the thread view. We just hit OK. That will recompute. And we get the thread in here. But our other operations haven't appeared. If we look back to the tree view, we can see the last operation is still hidden because we edited the hole. Just click on the last operation and press the spacebar. We have now completed the model, and we learned how to create thready holes, an introduction to the polar pattern, and how to attach a sketch on a non-planar face. In our next video, we'll understand when and where to use multiple profiles of different shapes, and these can be on multiple planes. We will see the return of our decision flowchart as we venture into the world of lofting. So I hope you enjoyed that video, and I hope to see you in the next lesson. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-fi at ko-fi.com/MANG0 or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.